Hi, everybody. Hello, members of the Planetary Society and members of the Planetary Society Book Club. It's Matt Kaplan, the Senior Communications Advisor nowadays, former host of Planetary Radio, back with you at a special time and with a very special author guest. I hope that you have all been enjoying and reading The Little Book of Aliens. It is such a fantastic, really fun book and very revealing. I had a great time reading it, just as I expect we will now be having a wonderful time talking to its author, Adam Frank. And remember that if you have joined us live, you can post your questions and comments about the book or anything else that we talk about to Adam in the chat right here in the member community, which I'm going to go to right now. And I will ask, because we've had audio troubles, I know, in the past. I hope everybody can hear me okay. Let me know in the chat if this is working right. Having said that, let me also add, if you're catching this as the recording, either on YouTube or at planetary.org, we welcome you as well. And if you are not yet a member of the Planetary Society, well, it's those folks who get to join the book club and more broadly be a member of our member community, which most of our 50,000 or so members are. And it has all kinds of wonderful benefits. And of course, it means that you would be supporting everything that we do at the Society. So take a look, if you would, at planetary.org/join and check out all the benefits and maybe sign up like I did a bunch of decades ago. All right, enough of that stuff, precursor stuff, and thank you everybody for letting me know it's coming in good, and hello to all of you as well. There's the book cover again. Not exactly where I wanted to go, but not a bad place. Here's where I wanted to go. Adam Frank, welcome to the Planetary Society Book Club. It's great to have you on board.
Hello, everybody.
There you go. Let me give you a little long paragraph bio of our guest. A lot of you I know are already very familiar with him and his work and his books, and hopefully have enjoyed The Little Book of Aliens as much as I have. Here's a bio. His very illuminating and entertaining blog is Every Man's Universe. Today's entry is about one of my new favorite shows, Pluribus. And whether it's, being part of the hive mind is a good place, is a happy place. Remember that Captain Picard said resistance is never futile, or was it Guinan? I forget. You can also check out his website, adamfrankscience.com. And he's an astrophysicist, among many other things. He holds the Helen F. and Fred H. Gowan Chair in the Department of Physics and Astronomy at the University of Rochester. In 2021, he was awarded the Carl Sagan Medal for Excellence in Public Communications by the American Astronomical Society. And anything with our co-founder's name on it is great by us. 2 years earlier, his book, Light of the Stars, was named the best book in science by the National Honor Society. I am especially impressed, Adam, that you were the science advisor to Marvel's Doctor Strange, which is, if I had to pick my favorite Marvel character, he'd probably be it. You may also have caught Adam anywhere else from CNN to Joe Rogan, or in any number of documentaries. And I like that he calls himself an evangelist of science. So Adam, we've picked up a lot more people now because they weren't all there at the very top of the hour. So once again, welcome Adam Frank.
Thank you. Great to be here. And I look forward to our conversation.
I'll throw that first question at you. Do you still feel that passion, beauty, and joy for all this stuff?
Yeah, no, that's the great thing about science is that I always feel it every day. I wake up and, I can't wait to get more science. And a lot of the work I do now often is pushing back against so much of the pseudoscience and science denial that is happening, which drives me crazy. The thing I'm always trying to tell people is the real science is so much better than the quote unquote fringe science, of which there is no such thing, that if people, took a minute to look at a leaf and consider what's going on with photosynthesis. That would be way cooler than whatever wackadoodle things they're thinking about, in terms of, conspiracy theories and UFOs.
Which makes me all the happier that you have made it to places like Joe Rogan's show, and that you were able to treat the subject of UAPs and UFOs so well in this book, which I hope is something that we'll get to. We won't get to everything I have in mind. Let's talk SETI. Has it been satisfying to see SETI go in your professional lifetime from nearly pariah status to an accepted line of research?
Yeah, that was pretty interesting. And I also feel that the work that we did that really drove that forward. So, I am the principal investigator on a grant that a group of us, I'm not the leader, part of this group that in 2018 or 2019 put in a grant that to study technosignatures, which is really, to me, I like using the term technosignature rather than SETI because of the connotations SETI has. And we feel like a large part of our job was to convince the NASA brass to stop having that sort of knee-jerk reaction against anything to do with intelligence, right? NASA has been funding a beautiful program in astrobiology for decades, but we're still putting things literally in the grant application language. It's saying, no, don't send us anything about intelligent life. Like, we only do dumb life. And it was like, come on, this doesn't make sense anymore. So it's been since 2019, since that first grant happened, that I think through a lot of the work that my colleagues and I did to sort of get NASA to see, like, look, they're all the same thing. You're going to be looking pretty much in the same wavelength bands for biosignatures and technosignatures. So why distinguish between them? So it's been very interesting to follow the transition in the community about the search for life to begin with, astrobiology at all, which when I was a graduate student wasn't even a field. And now the recognition that the search for intelligent life is no different than the search for, biospheres, microbial life.
You said that funding by NASA of this search for technosignatures and this gathering, which has a number of our friends in it, like your friend Wright. Oh God, it's just gone out of my
Jason
head.
Wright.
Jason Wright, of course. You said it changed your life.
It did, because before this, I wasn't really involved with SETI professionally. I had Woody Sullivan, one of the great pioneers, what I call the second generation of SETI.
Your mentor.
What?
Sorry, I said your mentor, wasn't he?
He was one of my men. He was not my PhD advisor, but that was Bruce Ballack. But I taught a class with Woody, and I loved Woody. I loved talking to him. I loved his broad thinking. But I didn't get involved with SETI at the time because I just sort of felt, well, first of all, it was still during a period where it was career suicide. But I was not a fan of radio SETI. I felt that there was still too much anthropomorphizing going on. Of sort of like, because really it required that the aliens send a beacon. The power requirements were so you were very much trapped with beacons. And then you got into a sort of, well, if they know that we know that they know that we know kind of thing. The whole discussions about 21 centimeter lines and such. It was trying to guess what their intentions were. And so while I thought SETI was awesome, I didn't really get involved with it. So, but I did start getting involved with, I do a lot of work in climate change, and I started thinking about climate change as a astrobiological phenomena. Basically, maybe any civilization that rises to the level that we have gotten to in terms of our energy harvesting would trigger climate change. And so that was actually my entree into thinking about SETI, or thinking about astrobiology and technosignatures in particular. And that's why I got invited to that amazing 2018 meeting where someone in Congress put in language in the budget that said, you shall give $10 million to technosignatures. And NASA was like, okay, what do we do with that? So they convened a meeting, and it was 3 of the most amazing days, because here are all these people who, have been on the fringe, at least their interests have not been part of the funding scheme. And now suddenly NASA's saying, what would you do if we gave you this money? And we had so much fun in that meeting, talking about everything. And out of that was born not only our grant, but other programs as well. It was really, I think, the initiation of the modern era of technosignatures in SETI.
And very exciting stuff as well. Do you see the search for technosignatures as replacing or just complementing traditional radio, and I suppose we should say, laser visible light SETI?
I think it's a compliment. But it's more than just a compliment. I feel it's a very powerful extension. You have broadened what you can do by quite a bit. And it's a difference in the strategy itself. Much of traditional SETI, well, as I said, was based on beacons, right? The initial idea was about communications. Someone is sending us a message. And that was both a strength and, I feel, a sort of weakness of traditional SETI. Now, this was just the brilliance of the original Frank Drake, et cetera, because this is what you could do, right? In science, you answer the questions that you have the tools to answer. And given power requirements, given what we understood, that was the way to do it. But the amazing thing about the exoplanet revolution, right? Now that we know exactly which stars have planets and which of those planets are in the habitable zone, it changes everything. And now, rather than look for signals being beamed to us, we can do what I like to think of as being stakeout. It's the cosmic stakeout. We're just going to sit with our cold donuts, our cold coffee and our crappy donuts, and we're just going to watch. We're just looking for signatures of a civilization going about its civilizationing business. We couldn't do that beforehand, and now we can. With optical, infrared, all these different wavelengths, we can just stare at planets and look for evidence that there's a civilization going about its business there.
In fact, you say, finally, we're ready, we're able, we're going to do it. Right. I'm also thinking, we mentioned Jason Wright, and I know that his team at Penn State, you talked about the study they did of how much we've actually completed a survey so far. And the answer is kind of both shocking and encouraging if you're one of those who looks forward to finding that we're not alone.
Yeah, so the public has this idea that every night astronomers are taking their telescopes and searching the heavens for life, right? And that's where you get there's a version of the Fermi paradox called the cosmic silence, the great silence. And the argument will go like, look, we've been looking for signals from intelligent civilizations since Frank Drake in 1960. We haven't found any, therefore they aren't there. But the reality is we haven't looked, right? So what Jason Wright and his students, it was actually a student project, they added up all of the SETI searches that have ever been done. And if the sky is the ocean, right? Let's use the metaphor that the entire sky and all the bandwidth that you have to look at is the ocean, how much of the ocean have we actually searched for in terms of life? Let's say instead of aliens, we're looking for fishes. How much of the ocean have we actually searched for looking for fishes? It turns out it's a hot tub, right? That's how much ocean we've looked at. We pulled up a hot tub worth of water. We didn't find any fish. And now are we going to tell people like, oh, there's no fish in the ocean because we looked at a hot tub? So, it really points to the fact that we just never really got started in that search during that early era or the first era of SETI. And so now, finally, we're really beginning the search and the entire sky is available to us.
So in the words of Enrico Fermi, as we've talked about many times on Planetary Radio on this show, where is everybody? And what this takes me to, I was really pretty thrilled to learn that you were on this team that did one of my favorite simulations, where you modeled one advanced technological civilization. And let's say that its technology is, not too far beyond ours, and how quickly they could move across the galaxy. Talk about that.
Yeah, that was a great project. So that was done by my former, or led by my former graduate student, Jonathan Carroll, who's still here at the professor here at the University of Rochester. And we took what's called agent-based models, and we made a model of the galaxy, and we just allowed abiogenesis. We allowed one planet out of the entire galaxy to form a technological species, and then we had it send out a spaceship. We had it send out a sublight spaceship, not moving very fast, and it crossed, the distance. It chose the nearest star, crossed the distance to that star, colonized that star, and then after a certain amount of time, sent out another ship. And so we just watched. We allowed this to happen, and then I think every certain number of years it would send out another ship, and we just watched the settlement front, propagate out from that initial site where a civilization had formed. And what we confirmed was what had been known that Fermi realized in that moment of brilliance in 1950, that in a very short time, before the galaxy goes through one rotation, that every star in the galaxy is touched. Every star system in the galaxy gets a visitor that colonizes a planet. So in that sense, the settlement front propagates very rapidly. And if that was all there was to the story, then you would expect that every planet in the solar system or in the galaxy had that civilization, a daughter of that civilization there. But so that's really what Fermi meant by the Fermi paradox, right? Why aren't they here now? And of course, if you believe in UFOs, then you're like, well, they are here now. But if you don't believe that, then you have to come up with an explanation. Why aren't they here now? And one of the things that we found was, if you allow civilizations to die, right, which, every civilization has a finite lifetime, then what happens is you end up with a steady state where civilizations are constantly dying, but then they are being replenished by new colony ships. And it turns out that for different sets of parameters, you can get big holes lasting for millions of years, tens, 20s, millions of years. So it may be that Earth was visited, and had a colony 50 million, 100 million years ago, but there'd be no evidence of that colony anymore. So, if all the assumptions that go into the Fermi paradox are true, that people want to colonize, that interstellar travel is relatively easy to do, still you end up with the possibility that, or with a condition where we are now, where we have no evidence of any aliens here now, and we don't see any in our near, in our the neighborhood. So you can have big unoccupied holes for geological timescales.
Well, let's hope that humanity beats the odds. Did you ever read that classic science fiction book from many, many years ago, A Canticle for Leibowitz? And it's civilizations that reach a certain level of technology and then destroy themselves and then go through another dark age and rebuild. A little bit like Foundation as well, which I think you're a fan of.
Yes.
Yeah.
Well, Foundation. Yeah, I'm a huge fan of Foundation. But no, I've never read A Canticle for Leibowitz. So thank you for putting that into my head. That should be in the list, because I've read all the other classic science fiction. I've read most of it. Yeah.
It's way up there. It's a terrific book. As I remember, it's been a long time. Let me feed you a few of the comments that we're getting from some of our members. When we were having those technical difficulties, Craig Griffin said must be high sunspot activity. But better was Kareem, who said aliens don't want us to hear this talk. Well, maybe. And then there have been a couple of comments. Thank you, Rhonda. She loves my shirt. I was going to wear one of my space ties, but when would I have a better opportunity to wear this shirt? So,
true, exactly.
Thank you.
Appropriate attire.
So I want to follow up on the work that you're doing, which is in the book, but there's so much more I'm sure that you can say about it. And you said that you're working with climate change as a technosignature, but also a challenge that we are facing. The other podcast I do as a volunteer, we did a whole season on climate change and communicating it. And so that's near and dear to my heart. But I wonder, what would you rather find with our wonderful new capabilities to sniff the atmospheres of exoplanets? a lot of oxygen, a bunch of carbon monoxide, or chlorofluorocarbons, CFCs?
I'm shooting for chlorofluorocarbons, right? So
Ah,
that was one of the first papers that our group did, is we showed that chlorofluorocarbons, which are a chemical that we don't think there's any way for nature to produce. Like if you see chlorofluorocarbons in an atmosphere, that is going to be very strong evidence that there's a technological civilization there. And so what we showed was that even a planet that had 10 times the amount of chlorofluorocarbons that we have now, which is not that much, would be very detectable even by the James Webb Space Telescope. So, that's a real nice example of a chemical technosignature in that could be in a planet that would be detectable. And of course, people say like, well, that's atmospheric pollution. What if they don't have pollution? But actually, you might put chlorofluorocarbons in your atmosphere on purpose, right? Because it's a great greenhouse gas.
Yeah.
So if you wanted, for example, to terraform Mars, if you wanted to make Mars warmer, you would pump Mars full of the atmosphere full of chlorofluorocarbons. So terraforming is actually, and our group has done a couple of papers on this. Terraforming is a very nice example of a potential technosignature. You should be able to see evidence for either for terraformed planets or ongoing terraforming from hundreds of light years.
So what are some of the other things that we ought to be looking for in terms of technosignatures? I mean, you mentioned Dyson spheres, and I know that there was that search a while back for the infrared that they would give off, right? And we apparently didn't find any. By the way, would you actually like to watch a Dyson sphere go off kilter and run into its star, as you said in the book? It would be quite a show, but no fun if you're on the sphere.
Yeah. That would be awesome to watch. But that's why it's probably not a sphere. I think even Dyson acknowledged it's not a sphere, it's a swarm. It would be a swarm of, not a rigid body. The other examples of technos, like, I'm not a huge fan of the Dyson sphere. I think it's possible, but it's not clear to me that everybody would build a Dyson sphere. I mean, what's interesting when you look at SETI is that the first generation of SETI theorists, Sagan and Kardashev and Dyson, they were all, sort of entranced by a certain kind of science fiction. They were all reading the same science fiction stories. The same ones you and I read, right?
Yeah.
And it led to a kind of very particular way of thinking about what civilizations would do. And this is the most important, I think, work that we have to do right now in the community, is to get beyond sort of the physicists doing history or anthropology, right? Because something like a Dyson sphere, it's a giant project that would require, decades, centuries. Would any civilization do that? Like, do we have examples in our own history of civilizations doing that? I'll tell you a funny story. In the very famous not Berggruen, but Bakunin meeting in 1974, I think it was, Carl Sagan and the Russians organized a SETI meeting in the Ukraine. And they invited lots of people, and they invited one historian. He was a historian from the University of Chicago. And everybody's up there giving their talks, all these scientists talking about, well, civilizations will do this when they get more advanced, and they'll do that when they get more advanced. And at one point, the historian stood up and said, no civilization in history has ever done anything like that. Right? And they were like, oh, you're in the humanities. You don't know what's happening. Forget you. And I think that's really something we need to sort of rethink. We need to really talk to our colleagues in history and anthropology to at least get an idea of, like, okay, what have human civilizations actually done, right? If we're going to try and generalize, let's at least be accurate about what, human civilizations have been done. So that's why, like, Dyson spheres, I'm not sure that anybody would build a Dyson sphere. But things like, you would be able to see artificial lighting, right? If a planet, if you had a Trantor-like planet, and I love this word, an ecumenopolis, a city planet, then the artificial lighting would show up in the spectra from that planet. If you're using a lot of solar panels, particularly if you take what we call a service world. If you take a world like Mercury, cover it in solar panels, and then beam the radiation, the energy back, that would actually, you'd be able to see the glint off those solar panels for even after the civilization died. The civilization could die and the glint would still be there. So we've sort of tried to make a catalog of possible technosignatures that we should look for. That's been our job. So there's really a whole range of things that might tell us from a distance that there's a civilization on that planet.
You remind me of conversations we've had about the Mars craze of the early 20th century, and the plans to light trenches full of oil so that we could signal the Martians from here. And were they trying to do that with us as well? I'll just mention in passing, one of the times that I got to interview Freeman Dyson, Be Still My Heart, he did say, all these depictions of solid spheres, those are not what I had in mind. And I said, by the way, did Star Trek The Next Generation, did the producers tell you that they were doing an episode where the Enterprise is trapped inside a Dyson sphere? He said, no one contacted him. Even though they called it a Dyson sphere, he didn't know until his family told him. You've mentioned, Dyson, you've mentioned Frank Drake. What a wonderful soul that was, or he was. You also mentioned this Russian-turned-Soviet scientist, Vladimir Vernadsky, who I had not heard of before I saw the book. And it seems like he was as much of a pioneer in some ways as Tsiolkovsky was for people who want to build rockets.
Right. So Vladimir Vernadsky is the most famous scientist you've never heard of. And so he was the guy who invented geobiology. He was the guy who invented geophysics. He was the guy who invented, so many different, geophysical chemistry. And really what he's most important for is he is the one who came up with the idea of the biosphere. He was the first one to really recognize that life would hijack a planet. And so his work is absolutely instrumental to our understanding of biosignatures now, because when we are looking for exoplanet biosignatures, we're not obviously we can't take a picture of a kangaroo bouncing around on an alien planet. What we're going to be looking for is the effect of the biosphere on the atmosphere. So we're looking at how life reshapes its planetary environment. And it was Vernadsky who first recognized in a series of lectures in 1924 that this was going to be the case. And it was the basis for understanding climate change. It's the basis for understanding sort of the history of life, what's called Earth system science. And it is now also the basis for bio and technosignatures. So he was really, it's hard to recognize or hard to grasp how far ahead of his time he was.
I want to go to some of the questions that we're starting to get from our members as well. And if you've joined us well after the start here, well, you missed the technical difficulties up front, so good on you. But our guest, of course, is Adam Frank, the author, most recently, of The Little Book of Aliens, which is much bigger in import than maybe in size, but it's pretty good size, too. Here's one from Tim. Here's a question. I don't think you mentioned this in the book, which was wonderful, he says. There's been a pretty big assumption over the years that confirmation of alien life, whether intelligent or not, would represent a huge societal change in humanity's outlook. Something our boss Bill Nye also agrees with. Now that we've made a lot of progress towards actually being able to find real evidence one way or another, and that we've seen 60 plus years of mass media aliens, do you still think that's true? In other words, when ET says either phones us or we find life, I don't know, bacteria on Mars or something much more sophisticated, do you think it will be as big a deal as we sometimes have been told it would be?
Yes. I think it would be. I think it would be one of the most important moments in human history, even if it's bacteria, because this is the weird thing, or this is the important thing. Life is unlike any other physical system in the universe. We can talk about how crazy black holes are, or how amazing galaxies are, but nothing compares to life. life is the only physical system in the universe that innovates, that creates, that goes beyond itself. And as of right now, as far as we know, it was an accident that happened on one planet, one time, right? But if we discover just one other example of life, then we can say that it's happened lots of times, right? If we know it's happened again, then there's no reason to think that like, oh, this is uncommon. And because life is unbounded in the sense that you cannot predict what is going to happen with the evolution of life. You don't know where it's going to go. You don't know what it's capable of. If we find another example of a genesis, then it may be that the universe is teeming with life and that we are part of a community of life, and that, to what extent has life gone on to shape the galaxy in ways that we're not even aware of? I just think because of life's, and this is really part of my research right now, is very much in what's called the physics of life. I'm very interested in understanding what makes a cell different from a rock on some very fundamental physics, philosophy level. Because life is so weird as a physical system that I think if we discover that we're not an accident, then we suddenly, the doors are blown open in terms of the possibilities. So that's why I still think that if we have hard evidence that it has happened somewhere else, then we are truly, deeply, not only not alone, but we're not unique. And that has profound consequences.
I'll say, boy. I just hope that that I'm around and that all of us participating in this are around when that happens. And it does seem like we're getting closer. So you're working on this great question, which we consider all the time: what is life? Will we necessarily recognize it? Will we be able to develop a definition broad enough that it will help guide us if it doesn't look like Mr. Spock, if it looks like the Horta, the silicon-based life in that almost 60-year-old episode of Star Trek?
Great episode, by the way.
Yeah.
I think that also is the frontier of the field. So what is called agnostic biosignatures and technosignatures, that's really where the field is at now. We spent 20 years sort of like really thinking about how Earth's evolution could imprint, signatures on it that, if something similar happened somewhere else, we might be able to find. But now people really recognize we need to go beyond that and ask questions about not so much the particular instantiation of the biochemistry that happened here on Earth, but what in general does life do that would leave imprints that we could recognize? So now we're starting to move to like a more abstract level of thinking about life. So for example, Sarah Walker, who I don't know maybe if you've had her on here, you should. Her book.
We have had her on Planetary Radio. Yeah, she's great.
Yeah, she's great. And so I really love her work. Looking for what are called information theoretic measures of life, or network theoretic measures of life. So for example, let's say you find a bunch of chemicals in a planetary atmosphere. You can try and go backwards and figure out the network of chemical reactions, like who's reacting with who based on the chemicals that you find. And she did some work that showed that the chemical networks that biology builds are entirely different from those that geophysics builds. So it may be that, you'll be able to look at a spectra from a planet, extract the chemical network from that and say, oh, this is clearly not a abiotic, a random network or a network, chemical network that just rocks alone would form. This has got to be something that life has imprinted. We're also looking at things that are information theoretic. We're looking for ways of looking at how the information measure in the biological signals that may tell you, or in the signals of the chemicals that may tell you that there must have been biology going on. So this is really the frontier that we're working on now.
What if it's machine life? Seth Shostak and a lot of other people are beginning to think that, well, that's the natural evolution. Either we're going to be replaced by the AIs, by ChatGPT, or we're going to upload ourselves into them. doesn't that change the search parameters somewhat?
Well, let me say that I am an AI skeptic in the sense. I think these are incredible tools. They are very powerful, but the idea of being able to upload yourself into a computer, I think, does vast injustice to our lack of understanding of what consciousness is. So, I think just like I'm very interested in the study of life, I think part of the problem is that we have this machine metaphor for life. We think that life is just a bunch of biological machinery. And I don't even think we're close to understanding the kind of organizational unity, that's the kind of a technical term, that makes something alive, right? We're not just machines. We are not machines made out of meat. And so that's why this idea of uploading ourselves into a computer, maybe it's possible, but I really think the kind of ways that we think about it are not up to the task of really understanding what it is we are as sentient conscious beings. Nonetheless, clearly, we are building machines that are going to have incredible capacities. So it still is possible that, and of course I could be totally wrong, right? I've been wrong a lot in my life. So, don't be betting on anything I say. But I do think that even if I am right, there's a strong possibility that what we will detect will be machines rather than organic life. But that's okay. I mean, that's fine. Like, we might very well find the machine avatars of a civilization. It'll still tell us that there was somebody built it, right? Whether it's fully sentient in consciousness or not, somebody built it. So it tells us that there is intelligence out there.
With just a few minutes left that you've got for us, because we could go for hours and hours, I'm going to bring up, and I hope nobody will be critical of this, the portion of the book that you devote to those people who believe that they're already among us. We mentioned it earlier, those UAPs, now what we call unidentified flying objects, unidentified aerial phenomena. I compliment you for taking this on and for your approach to it. You write, regardless of whether you believe this is what's happening or not, the explosion of UFOs as aliens into global culture has had a profound and mostly negative effect on the scientific search for life beyond Earth. So how do we move forward with this? Because there sure are a lot of folks who think that, they're out there turning on a dime, ignoring inertia and momentum and doing stuff we can't.
Yeah. Well, I think, as I say in the book, I am completely open, and I think it would be useful to have a transparent, open investigation of UFOs and UAPs. Let's go collect some data and see what it says. And it would be useful because, there definitely pilots see stuff, right? And we don't know what it is. My tendency is to think that it's what they call peer state adversaries. But either way, it's there, and we should do the study. And also, it'll show people how science does its work, right? There's so much science denial. Why not take a subject that everybody's interested in, do this, big, open, transparent, study, and show people like, oh, this is how scientists know what they know. That would work for everything, for convincing people about climate change, teaching them how vaccines are made, And listen, I'm open to the possibility that, UFOs are an actual technosignature. That could be true. There's no data right now that is anywhere close to the quality needed to, confirm that, but it could be true. So I'm more than open to doing that investigation. So I think, being open-minded is part of what being a scientist is all about. We should put the biases behind us of the past and do this work. And like I said, it would be no matter how it goes, it would be a great way to teach people how science works.
Yeah. I may come back to that theme, but I've got to use this opportunity. You have so many wonderful bits of humor in the book. And one of my favorites is on this subject. If the UAPs/UFOs are real, the question is, why are they so really, really terrible at hiding from us? And you say, have they sent us their D team, the one that doesn't The one that doesn't know which button engages the cloaking field? Are they just a bunch of Zorgovian teenagers who stole their parents' saucers and are out for a joyride? Great stuff. I have to, because I want to credit a dear old friend of mine who passed away some years ago, John Donan, who used to do college radio with. And John Donan did a whole show once on his theory, Hot Rods of the Gods, which is that ancient alien teenagers used the primordial Earth as a drag strip, and life on Earth evolved from their hydrocarbon emissions. Is that not excellent?
That's great. That's really good.
Oh, I miss John. To pick up on that theme, the direction I think you were going in, I'm sure you will agree that the search for life and intelligence also has this capacity to teach us about this way of knowing that we call science.
That's really what it is. I mean, I've been doing science communications, as they call it, for a long time. I mean, my hero growing up was Carl Sagan, right? That is who drove me into science. He's the one who drove me into, wanting to communicate the beauty and joy of science, because his books, not only when you read a Carl Sagan book, not only did you learn about relativity, you learned about Venice, in the Renaissance. It's like, oh, I didn't know that. Okay, great. The search for life in the universe is something that everybody has an opinion on. Everybody is motivated by. Everybody is excited about it. The first line in the book is everybody loves aliens. And so what better way of showing people how, science works? I've used this all the time. There's the great line from the X-Files, I want to believe. Well, the great thing is, no, I don't want to believe. Believing and $5 will get me a cup of coffee at Starbucks, right? Belief is worth nothing in this case. I want to know. And there's only one way to know about the physical world, and that is through this process that collectively human beings came up with called science. So yeah, we should use the search for life as a primary way of showing people how scientists know what they know.
Hear, hear. Here is a line I absolutely love. The essence of good science is constrained imagination. That's right out of your mouth, off of your keyboard anyway. There's one other, as we very close to the end of our time that we can spend with you. And I hope the rest of you will stick around and we'll talk for a few more minutes and maybe go through some of these other comments that you're making. Great stuff that you're submitting. Here's the line. The weirdest thing about being human in the early 21st century is that we know so much, and yet we're still so completely clueless. We really have a lot to learn still, don't we?
Yeah. And especially with this question, right? Because whether or not there's other civilization, whether there's any other life or other civilizations, it's such an important question that it's so weird to be like, alive when it's like, oh, we know how to ask the question. We know what the answer to the question might look like. And we're, sort of, pulling the team together to go answer the question. And yet, I may die before the question's answered. It's like, oh, come on, right? So it's kind of frustrating because think about it, like the world right now seems like such a mess, right? And I talk to my kids about this all the time. I'm like, has anybody done better? Like, is it just us? Are we just a mess? Human beings, I mean, that like we can't get it together. And maybe every other civilization in the universe is like, nuclear weapons, you built nuclear weapons. Like, what is wrong with you? So it's like just having somebody else to talk to and some other history to compare would be so helpful. And it's so funny that we're like that close, but not, we're still not there yet.
I don't know about you, but they can't build the Habitable Worlds Observatory soon enough. I want to be here, right?
Absolutely.
Here's your closing line in the book. You, me, and every other person alive today, we're the lucky ones, in spite of what you just said. We all carry the questions our ancestors asked about life and the universe, but we alone get to be there when the answers emerge. Enough waiting, enough talk. The time has come to find out for ourselves. Let's go. Adam, thank you for helping to take us there.
Thank you. This was a really wonderful conversation. I'm glad you liked the book. When you write a book, you're hopeful somebody reads it. So thank you very much for your time and your consideration of the book. This was a great conversation. Thank you.
Thank you.
Also,
Yeah.
I love the Planetary Society. You guys are the best. You've always been the best. I'm so grateful for the work that all of you do. So,
Much appreciated. That just may be heard, that quote, somewhere else, because coming from you, Adam Frank, I think we can get some mileage out of that. By the way, I do want to tell everybody, but just in the last few seconds before you go, don't stop with that last line in the last chapter. Adam's list of recommended readings is absolutely outstanding. It's one of the best I've seen of any of the books that we've considered on the book club. Adam, I better let you go. Thank you so much. It is a pleasure, and I hope we get to talk again. And there they go.
Take care, everybody.
UAPs.
They're coming. Bye-bye.
Bye-bye.